In this video, I'm going to talk about the role of parser. So the parser, the other name for the parser is the syntax analyzer. Syntax analyzer or parser, is a second phase of the compiler. So what is parser actually? Parser is a program that obtains tokens from the lexical analyzer. As we all know that lexical analyzer is a phase one of the compiler. So during lexical analyzer, we give the source program as input and we get the token as output. So whatever token we got it from the lexical analyzer, that will be given as an input for the parser. And once it goes to the parser, it will construct the parse tree, which is passed to the next phase of the compiler, that is a semantic analyzer for further processing. The parser implements the context-free grammar for performing error checks. So this is a diagram for parser. As all know, in this diagram, the first two phases are mentioned. First phase is a lexical analyzer and second phase is a syntax analyzer or parser. So here the source program is given as an input for the lexical analyzer. So the output for the lexical analyzer is a token. So the token is given as an input for the parser. So the parser will construct the parse tree from the token. And whatever token we got from the lexical analyzer, that will be stored in the symbol table. And parse tree is given as an input for the next phase, that is a semantic analyzer. And what are the functions of the parser? So parser actually, first function, it verifies the structure generated by the tokens based on the grammar. And main function of the parser is to construct the parse tree, and if any errors are there, it will be reported by the parser. As we all know that during the syntax analyzer, it will find out the syntax errors. If any syntax error is found in the during the syntax analyzer phase, it will be reported by the parser or syntax analyzer. So it reports the error, and also it performs a error recovery. Once the syntax analyzer reports any error, that errors are recovered by the parser. So it performs the error recovery also. And what are the issues in the parser is, parser cannot detect errors such as variable redeclaration, variable initialization before use, data type mismatch for an operation. So these are the issues that are not addressed by the parser, but these issues are handled by the semantic analyzer phase. And there are two types of parser mainly. One is a top-down parser, second one is a bottom-up parser. So what is meant by top-down parser is, top-down parser construct the parse tree from top to bottom. That is root to the leaves. So that is top-down parser. On the other hand, bottom-up parser is a reverse of the top-down parser. So it constructs the parse tree from leaves to the root. That is a bottom-up parser. What are the types of top-down parser is? There are two types. One is a recursive descent parser. Second one is a LL of 1. In the bottom-up parser, it mainly classifies into two types. One is a LR parser and other one is a operator precedence parser. So LR parser in turn divided into 4 categories. First one is LR of 0. Second one is SLR. So what is meant by SLR means simple LR parser. And third one is a LALR parser, that is LALR 1. So LALR 1 means look ahead LR parser, and CLR parser means canonical LR parser. So what is meant by LR denotes for is, L denotes for leftmost derivative, left to right scanning. The L, this left and L denotes for left to right scanning. This L denotes for left to right scanning, and this R denotes for rightmost derivation in reverse. These are the 4 types of LR parser. LR of 0. So as I told, LR means L denotes for left to right scanning, and R denotes for rightmost derivation in reverse. SLR denotes for, S denotes for simple, and LALR, LA denotes for look ahead, and CLR canonical. And as I mentioned, there are two types of parser: top-down parser and bottom-up parser. In top-down parser, parse tree is created from top to bottom, that is starting from the root. And bottom-up parser, parse tree is created from bottom to top, that is starting from the leaves. And both top-down and bottom-up parser scan the input from left to right. So as I told, in LR, L denotes for left to right scanning. So both top-down parser as well as bottom-up parser scans the input from left to right, but one symbol at a time. And efficient top-down and bottom-up parsers can be implemented only for subclasses of context-free grammars. So LL for top-down parsing and LR denotes for bottom-up parsing. Next one is grammar. What is grammar? What is grammar means? Grammars are capable of describing most but not all of the syntax of the programming language. It defines specific rule or structure for defining the languages. Normally, the grammar is defined by four tuples, that is G denotes for grammar, equal V, L, T, P, S. As I told, this G denotes for grammar. What is this G denotes for? G denotes for grammar. And V, what is V denotes for? Set of variables. And T denotes for set of terminals. T denotes for set of terminals. P denotes for set of productions. And S, this S denotes for a start symbol. What is this S denotes for? Is S denotes for a start symbol. There are different types of grammar: regular grammar, context-free grammar, context-sensitive grammar, and phrase structure grammar. So now we are going to discuss about the error handling. Mainly in compiler, four kind of errors can happen: lexical errors, syntactic errors, semantic errors, and other errors. What is lexical error? So lexical errors means such as misspelling an identifier, keywords, or operator. For example, so if is a keyword actually. What is if? Normally if. So if is a keyword actually. When I type if, instead of I'm typing if I type fi, this is a misspelling an identifier or keyword or operator. Okay, these kind of errors are called as lexical errors. When we are scanning the expression, keyword sometimes may be misspelled, identifier may be misspelled, operator also may be misspelled. So these kind of errors are called as lexical errors. Second one is a syntactic errors. What is syntactic errors? It is such an arithmetic expression with unbalanced parentheses. For example, assume that I have A plus B. So A plus B, C equal to A plus B. So assume that here I have missed one parenthesis or bracket. Okay, C equal to A plus B. Here close parenthesis is missing. So these kind of errors are called as syntax errors, syntactic errors. In C language, assume that integer A equal to 10. If it is a declaration statement, it is ended with a semicolon symbol. Sometimes if I am missing the semicolon symbol, that will be the syntactic error. Third one is semantic errors. What is meant by semantic error is, it is such an operator applied to an incompatible operand. Okay, it is mainly happens due to data type mismatch. Sometimes you are using a variable as an integer, but inside your program you are using that same variable as a floating point or some other data type. So in that case you may get a type mismatch. So these kind of errors are called as semantic errors. Okay. Now what is the goal of this error handler, syntax analyzer error handler is, syntax analyzer is expected to take the following measures on the occurrence of syntax errors. Report the presence of errors clearly and accurately. Recover from each error quickly enough to detect subsequent errors. Add minimal overhead to the processing of correct programs. These are the error handler goals. Now, the different strategies. What are the different error recovery strategies are used by the parser to recover from the errors once it is detected? The simplest recovery strategy is to quit parsing with an error message for the first error itself. There are 4 error recovery strategies: panic mode recovery, then phrase level recovery, then error production, and global correction. We will discuss one by one what are the different error recovery strategies. Again, I repeat, there are 4 recovery strategies: panic mode recovery, phrase level recovery, error production, global correction. What is panic mode recovery? So panic mode recovery is one of the easiest method of error recovery strategy, which prevents the parser from developing infinite loops. When a parser finds an error in the statement, it ignores the rest of the statement by not processing the input. Okay. When a parser finds an error in the statement, it ignores the rest of the statement by not processing the input. So the parser intends to find the designated set of synchronizing tokens by discarding input symbols one at a time. Synchronizing tokens are delimiters such as semicolon or parenthesis. The advantages: simplicity, never get into infinite loop. Disadvantage: additional errors that cannot be checked as some of the input symbols will be skipped. This is a panic mode recovery. Next one is a phrase level. Phrase level recovery, and it is a technique used to fix syntactic errors in compilers. It involves making local corrections to the input string after an error is detected. So when a parser finds error, it tries to take a corrective measures so that the rest of the inputs of the statement allow the parser to parse again. This is a phrase level recovery. The local correction may be replacing a prefix by some string, replacing a comma by a semicolon, deleting extraneous situation, semicolon, insert a missing semicolon. This is a local correction. I repeat, what is local correction? So the local correction may be replacing a prefix by some string. Second one, replacing a comma by a semicolon, deleting an extraneous semicolon, insert a missing semicolon. These are the phrase level recovery. Third one is a error production. What is error production? The productions which generate erroneous constructs are augmented to the grammar by considering common errors that occur. So these productions detect and anticipated errors during parsing. Error diagnostics about the erroneous constructs are generated by the parser. Fourth one, the global correction. What is global correction? These are algorithms which make changes to modify an incorrect string into correct string. So these algorithms perform minimal sequence of changes to obtain global least cost correction. When a grammar G and an incorrect string P is given, these algorithms find a parse tree for a string Q related to P with a smaller number of transformations. The transformation may be insertions, deletions, and change of tokens. What are the advantages of the global correction is, it has been used for the phrase level recovery to find optimal replacement strings. And disadvantage, this strategy is too costly to implement in terms of time and space. Next, what is context-free grammar? Context-free grammar, as I told in the previous slides, it gives a precise syntactic specification of a programming language. The design of a grammar is an initial phase of the design of the compiler. It has 4 tuples actually. What are the 4 tuples are? Capital V, G means grammar, capital V set of variables, capital T set of terminals, capital P set of productions, and capital S, that is a start symbol. So what are the terminals? So terminals are symbols from which the strings are formed. The example for the terminals are lowercase letters, all the lowercase alphabets, A, B, C up to Z, then operators, whatever arithmetic operator, relational operator, like arithmetic operator denotes for plus, minus, star. Relational operator means less than or equal, greater than or equal. All are operators, all are terminals. Punctuation symbols, that is comma and parenthesis. Digits, what is digits denotes for 0 to 9. And keywords like boldface letters, ID, identifier, and if is a keyword. What is non-terminals? So non-terminal means all the uppercase letters are non-terminals. Capital A, capital B, and capital C. And lowercase italic names. For example, expression, EXPR, and statement. These are the non-terminals. Start symbol, it is the head of the production stated first in the grammar. That is a start symbol. And production is in the form LHS tends to RHS, or head points to body, where head contains only one non-terminal and body contains a collection of terminals and non-terminals. Example, so this is an example. These are the grammar actually. E tends to E plus T or E minus T or T. T tends to T star F or T by F or F. F tends to open bracket capital E close bracket or ID. So here what are the variables? Are non-terminals. So all the uppercase letters are non-terminals. Capital E is a non-terminal, capital T is a non-terminal, capital F is a non-terminal. So these all are non-terminals. And terminals, what is terminals? Whatever the operators, punctuation symbols, bold face letters, all are terminals. So here plus, so plus is a terminal, minus is a terminal, then star is a terminal, then slash division is a terminal, then open parenthesis, close parenthesis, then ID. So these all are terminals. Start symbol. So what is the start symbol here is capital E. So capital E, whichever the head of the production, that will be the start symbol. So in this, S is an start symbol. So capital E is a start symbol. And the set up production. How many production we have? First one, E tends to E plus T. That is production number 1. And T tends to E minus T. This is production number 2. E tends to T. This is production number 3. And T tends to T star F. That is production number 4. T tends to T divided by F. This is production number 5. And T tends to F. This is production number 6. And F tends to open bracket E. This is production number 7. And F tends to ID. This is production number 8. So totally we have 8 productions. For writing a grammar, begin with a string consisting of a start symbol. Apply one of the productions with a start symbol on the left hand side, and repeat the process of selecting non-terminals, the string, and replacing them with the right hand side of the corresponding production until all the non-terminals have been replaced by the terminal symbols.